Hi dear students. So today we will be discussing about the accuracy and preciseness or precision. So what are accuracy of a reading? Which value or which reading will be an accurate value, and which reading in a measurement, which reading will be a precise value? That things we will be discussing today. Okay. So first of all, let us come to the term accuracy or accurate. So we will see what is an accurate reading or what is the accuracy. Suppose if you are having a material of a length, this is a true value it is given as 2.7 centimeters. This is the length of actual length of a material. And three of your friends are measuring the instrument with some the material with some measuring instruments, and one of your friend obtained the value as 2.6 and other one obtained it as 2.5 and other one it obtained as 2.3. So the value that they have measured for a particular thing of the length, the true value as 2.7 centimeter. So from these readings, if you are going for the term accuracy or the accurate reading, that will be 2.6. How did it come? That we are going to see now. From the various values that we have measured, whichever the value is more related to or more closer to the true value, that will be the accurate value, and that is known as the accuracy in the measurement. Okay, so 2.6 is the accurate value for this measurement. Suppose if you are having another reading as a 2.65, then the accurate value will be 2.65 only, because the true value it is 2.7 and 2.65 is more closer to 2.7 than 2.6. So the accurate value will be, then it will become 2.65. Okay, so that means the reading which is more closer or more nearer to the true value, that is known as the accurate value or accuracy. Now come to the preciseness. The preciseness is actually which is representing the resolution of a reading, of the reading. Okay, the resolution of the reading. So how can we find out the resolution, or what is the resolution? Actually, suppose if you are having measuring, suppose if you are measuring the length of a particular thing with the centimeter scale, then you know that the limit, it is the least count of a centimeter scale, it is 1 millimeter. That is the least most value that you can measure by using the centimeter scale. Instead of that centimeter scale, if you are using a vernier caliper, then there will be 2 decimal points. Suppose if you are measuring a material of the length 2 point something, okay, x, we do not know how many digits are there after after the decimal point. Okay, so this is the value. Okay, suppose many values are there, many decimal points. After the decimal point, the decimal values are so many number of values are like 33333, likewise it is there. Just assume if you are measuring the length of this material with a centimeter scale, you can only obtain till 2.3. The after points which cannot be measured with the help of a centimeter scale. Are you getting? Yes. Actually, suppose the length or true value or the length of a material, the true value it is found by using some other instrument. Okay, it was found like 2.33333. This is the actual true value it is. By using a centimeter scale, you know that 2 centimeter and 3 millimeter, that is the limit, and afterwards we cannot put any decimal numbers after this limit, isn't it? Suppose if you are measuring this same material with the help of a vernier caliper, then the value will be 2.33, isn't it? Because the vernier caliper for the least count of a centimeter scale, it is 0.1 centimeter, whereas that of the vernier caliper is 0.01 centimeter. Again, if you are going for the screw gauge reading, okay, that will be 2.333. The remaining it will not be possible to measure with the help of a screw gauge. Least count of the screw gauge, it is 0.001 centimeter. So you can see here the decimal points are more in the third reading. That means the resolution of the reading is more for the third one, and it is more accurate. Also, it is more accurate to the true value. Suppose instead of this 333, if you are obtaining it as 2.2555, let it be like this. Okay. So the question is that which one will be the accurate value and which one will be the precise value? Okay, which one will be the accurate value and which one will be the precise value? Here the accurate value, that means which is the value which is more closer to the true value. Here our true value is this one. Hence, the 2.33 will be more closer to the true the measurement 2.33 will be more closer to the true value 2.3333. So this will be the accurate value. So my question is that will it be the precise value from these three? Will it be the precise value? Do you think so? No. Here for the preciseness we are just focusing on the decimal points or we can say the decimal numbers, or we can say the resolution of the reading. So here the reading 2.2555 is the reading with higher resolution. So if you are saying which one is the precise value, then this 2.2555 will be the precise value and accurate value will be 2.33, that will be the accurate value. So I think you understood these things. Okay. So regarding accuracy and preciseness. So accuracy, the value which will be more close, or the accurate value can be defined as the value which is more closer to the true value, that is the accurate value, and the preciseness is regarding the resolution of the measured values. The whichever the value is having more decimal points or more decimal numbers, okay, then that will be the precise value. For getting higher the precision or preciseness, you have to use the measuring instruments of very low least count, as like the screw gauge. If you are comparing both the three, centimeter scale, vernier caliper and the screw gauge is the instrument which have the ability to measure the precise values. Okay. So now we are going to see the errors that can be occurred in the measurement. Okay. Okay. So come to the errors. So whenever you are measuring some length or some other measurements, okay, whenever you are doing some experiment, you have to take the measurements. Then there will be the chances of errors. Okay, errors will happen. So now we will be going to see some of such kind of errors which are mainly affecting our measurements. Okay, common errors. So majorly the errors are separated or differentiated into three as systematic error, random error and least count error. Okay. So regarding the systematic error, which will be in one direction, the systematic error, maybe in positive direction or in negative direction. Okay. And which will be a regular, we can say that the systematic errors are regular errors. Okay. regularity will be there, maybe in a positive or maybe in a negative direction. So, now the systematic errors are again separated into three, that is instrumental error, experimental error and experiment error and personal error. So, first of all come to the instrumental error. Maybe suppose if you are having a broken scale, so it is not having till the 5 centimeter portion, it is not there, that is 1 to 5 it is there, 0 to 5 it is not there, and you are going to measure some length of some material and you got that one as 10 centimeters. Okay, you are beginning it with the 5 centimeter and you got the value as 10 centimeter. Where there will be any chances of any others, any errors? Are you feeling that? That is, you have started with the 5 centimeter and you got 10 centimeter, that means you have to minus that remaining 5 centimeters. 10 minus 5, that will be the actual reading, isn't it? Same way, in some cases, some of the thermometers means not over the infrared thermometers. If you are using the mercury thermometers, after when it get old, that the preciseness, or we can say the accuracy, will be get reduced. Okay, such a time it cannot give the better result or a true value, it cannot provide. Such kind of errors, that errors which are related with the instruments, the instruments that we are using for the measurements. Okay, so such kind of defects or some fluctuations. So, such kind of things which are affecting the instruments, or the errors happened due to the inaccuracy or less calibration of our instruments, are known as instrumental errors. Okay. Actually, it is given in the textbook, you can read that one and you can copy that to the notebook as well and study it. So, the instrumental errors that arise from the errors due to imperfect design or calibration of the measuring instrument. Okay. The zero error, I think those who have attended the practical sections know that zero error is that we have discussed in the case of the screw gauges, we have discussed it. So, such kind of errors that are known as the instrumental errors, the errors which are related to the imperfection or in the calibration power, imperfection in the calibration power of the measuring instruments is known as instrumental errors. Now, the next one is experimental setup errors. So, that what to say, the fluctuations in the atmospheric pressure, the temperature, as well the imperfection in such kind of the experimental setup, wherever the laboratory where the temperature can affect some of the experiments, the atmospheric temperature, the pressure can affect it. So, regarding the experimental setup, the place where we are doing the experiment under the surrounding, which will affect the measurement, such kind of errors are known as the imperfection in experimental technique or procedure errors. So, for an example, suppose if it is asked to find out the room temperature, and if you are going near a hot place, suppose if you are in the kitchen, the stoves are there, okay, that the wooden stoves. So, if you are sitting there and if you are measuring the temperature of the atmosphere with the help of this thermometer, then it will be very high value, 40 degree or 50 degree value will be there. But if you want to get the accurate or precise value, you are supposed to get outside your room and be there in the atmosphere for some time with the thermometer and an open place, and you have to measure the temperature like that. So, that error which is happened over there, that was the experimental surrounding related error. So, such kind of errors are known as imperfection in experimental techniques and or procedure. As well, some of the machines have to be operated in, there may be some particular steps will be there, okay, for operating some the equipments, instruments, okay. So, if you are not following such kind of things, then it will become an experimental error as well a personal error, okay, that will become that the chances of personal error will be there more. So now come to the personal errors. Personal errors. Actually, the personal errors which will be generated with the carelessness of the particular person who is taking the measurement. Suppose, what to say? Suppose you know that regarding the zero error in the case of a screw gauge, you know about that. Or if you do not know, then also. And first of all, you have to find out that error, isn't it? How much error is there on the zero deflection point, okay, 0 point. Then you have to subtract or add that value to the obtained result, isn't it? That is the negative or positive error. Negative error can be overcome with the help of adding that error division into with our value. As well, the positive error can be regulated by subtracting the error division with the obtained value. We can obtain. So, if you are not doing such kind of things, if you forget to do such kind of things, then the error occurred is a type of personal error. As well, if you are roughly handling the instruments, equipments for the experiment setup, then also there are chances of happening the errors, and such kind of errors are known as the the personal errors. Now, let us come to the random errors. Random errors are happening irregularly, and it can be both in positive and negative direction. And what are the other things which are given in the textbook? Just to go through that one. Okay, this kind of random errors are happening due to the unexpected fluctuations in some of the values, experimental values, or some the atmospheric pressure, temperature, voltage, current. Suppose sometimes maybe an unexpected change, a gradual, a huge variation may happen suddenly. Such kind of errors, then also in the measurement of some particular value, errors will be happening, and such kind of errors are known as the irregular or random errors. Now come to the least count error. Okay, these are the major errors, and now least count error. Okay, in the case of least count error, we have already discussed that if a body with a true value of 2.333, okay, that is 2.333, this is the true value of a material. If you are measuring it with the centimeter scale, you will get only 2.3 centimeter. If you are doing it with the one more 3 is there. If you are doing it with the vernier caliper, you can obtain the value as 2.333 centimeter, and if you are using a screw gauge, it will be 2.333 centimeters. So, our true value was 2.333 centimeter, but we have used a centimeter scale of the least count 0.1 centimeter, hence we could obtain only the 2.3 centimeters. The remaining 0.0333 centimeters was an error that we couldn't measure with the help of a centimeter scale. But when you are using the vernier caliper, you could measure 2.33 till 2.33 you can measure. The remaining 0.0033 was again become an error with. That is the difference between the measured value and the true value. And in the case of a screw gauge, if you are measuring the same distance with the help of a screw gauge, the reading will be 2.333. Means again there was a slight error, it means 0.0003 error is there. So, you can see that when the preciseness is increasing, okay, the precision is increasing, that means the chance of reducing the least error, the chance of reducing the least count error is increasing. Okay. So, we can reduce the chance of happening the least count error if you are using a high precision or high precision equipment for the measuring. Okay. If the preciseness is more, then the chances of the least count error will be less, or the least count we can reduce the least count error if you are increasing the precision of the equipment material. So, suppose if you are taking the length of something, it is better to use the screw gauge instead of vernier caliper and centimeter scale. to reduce the least count error. And one more thing, the random errors can be, it will occur. So how can we reduce the random error? You have to take a particular reading. Suppose if you are taking the length of a particular, suppose a desk, you are taking the length of a desk, you just take that for 5 times, 5 different times. So maybe some errors happen and some variations will be there in the values. Then what you have to do? You have to just take the mean of that values. So regarding that things that we will discuss tomorrow, that the mean, absolute mean, and reduction of the, what to say, the error, percentage error, all those things we will discuss tomorrow. Just go through those things in the textbook, and also you just follow the exercise portion. As well for the practicals, you just if it is possible, you just come for the practicals as well. Maybe the practicals will not be repeated, okay, in the case of physics. So as possible, you just come and attend the practicals at least, okay. Thank you.